A marketing strategy refers to a business's overall game plan for reaching prospective consumers and turning them into customers of their product and services. A thorough marketing strategy covers the 4 P's of marketing: product, price, place, and promotion. In this video, you will learn about how data science helps retail store in planning strategic marketing campaign for effective campaigning. So put on your thinking hats and let's get started with this session on planning strategic marketing campaign using data science. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
So today what we are going to, guys also have got the invite regarding the marketing, how to plan the strategic campaigns, all these things we will see. So basically we are not going to see from the digital marketing or a marketer perspective. We are going to see from the data scientist side, because you guys are data scientists and I have done PG diploma in digital marketing as well. So I know that what are the concerns that these guys face, or the digital. I'm not working in that field, but I know that what happens, right? What are the challenges digital market face? And if you have a clear-cut data analysis done, you know who's your audience, you know where you have to focus, then that would be best for you. Why it would be best? Because you can plan your campaigns accordingly. And if your campaigns are rightly planned, then everything that you are doing, your money would be returned to you, right? Because everything at the end comes to cost. That why I'm putting in this much, how much I will get back, what is the amount that I'm spending to get one customer onboarded, right? So that's what we are going to see from a data science perspective, that about these campaigns from this data set, what are the campaigns that I have, and what's the reason on what these campaigns are based on what the spend is, purchase, all these things are based on. So this is divided into 2 parts. One part we will cover first layer of analysis. In second one, we will go into other layer of analysis, as well as we will learn new libraries also, which would be, at least I would say, for the management level people or the mid-senior level people who don't want to write so much of code, just 2 or 3 lines of code, quick click, and you will get all the visualizations and everything ready. That is not for the people who are on the development front, because that's not, this is just like a POC sort of a thing. I have got 1 week or 10 days in hand. Let me quickly get first glimpse of my data. That's what we will learn in the next session. So first session, we will concentrate on the EDA and some data transformation, feature engineering, and getting first level of recommendations out. Okay, so let me move ahead from here. So guys, this pretty much everybody knows that what's the cycle. I will just take few minutes to cover few of the cases in retail marketing aspects, since we are talking on that field, so that even you are aware of in this domain what are the most famous scenarios available in the market, okay, or being worked upon in the market. So project analysis, if you're working in any data science project, the very first thing that you do is understand, the very first thing is that you have to understand the business requirement. What is their specification? What is their bottleneck, their pain point? Until unless you have empathy with them, you won't be able to solve their problem. So once is the specification, then get the data collected according to that. Have a descriptive statistics done, do a diagnostics analytics on that what are the, why this is happening, or what is the problem with the data and all that. Then based on that, if required, if your specification is this, that you have to do a prediction, do a predictive analytics, and then prescribe. That is your recommendation. Now this predictive analytics totally depends that I would be getting into, means my specification is to predict something or not. But this prescriptive analytics, you can even do based on diagnostics and descriptive. This is just a recommendation that you are telling business that boss, this is what you have and this is how you have to solve your problem, or this is good, this is bad, and blah blah blah. So this is a cycle that you have which goes on in the data science so retail domain. If you see, I have listed down only few over here, but these are to the best of my knowledge of what I have seen in my career, worked upon. These are the ones that are most spoken. There are many digital marketing aspects, many things are there, but this is a few of the things that I want to bring to your notice. Recommendation system, personalized marketing, price optimization, inventory management, customer sentiment analysis. Recommendation system, many of you would have seen that joke floating around that Amazon, somebody went to buy a fan and Amazon said you buy a stool and a rope also so that you can commit suicide. Right. So that's the recommendation system. I'm not saying that that's good, but overall, that's what it is recommending. You buy Alexa, they will say that people have bought a bulb also for that. This, AI enabled bulbs also, or any other electrical appliances, that this is the best recommended one for you. You buy from some buyer, they will recommend you another buyer. That's the recommendation system. Again, it is AI enabled. AI is nothing but part of data science, but is a subset under data science. Then you have personalized marketing. That's where the thing comes into picture. Means it's a very broad aspect. This is digital marketing that we are talking about, or a physical marketing on your mobile phone. Tomorrow, a Starbucks example, you would have seen in your case studies, right? What Starbucks does. Starbucks concentrate on giving you personalized experience on their app by giving you offers on the product that you like, and with that they enhance their sales. So over here also, once you analyze whether it is country specific, whether it is age specific, accordingly you can't sell kids apples to a person who is in 70s, right? You can't recommend that. That doesn't make any sense. There was one of the case studies that came out that one person was in US, it is based out. I don't know how many of you know this thing, but one person was surfing on net, and daily he was getting some or the other pop-ups on his Facebook and everywhere, that about all your maternity products, okay, all your kids and maternity product. And he was very irritated with that thing. Why this is happening? He went ahead and he raised a complaint. Why you guys are showing me such ad? I'm not relevant to that. Nobody in my house is there who is pregnant or so. So through that they came to know that no, somebody is surfing over there. There are crawlers which understand this condition, that what the sites you are suffering, that's surfing, and that's where you are having this cookies and all enabled, right? And that's why we say go to incognito mode and do this thing. So what they did is that they said no, somebody was surfing. Then he came to know that his daughter was using this and she is pregnant. Okay, so that's one example. Price optimization. What is the best price? Whether it is geographical, based on the geographical location. If you have a store situated in airport and outside, definitely the prices do differ. But what is the best price that you want to keep? Based on your surrounding, who are the people who are coming? Who are the people in that location that will come, or what is the price that I'm paying as a rent? It is my own shop or not? What are my competitors paying for that? Everything is kept in mind, and then price optimization is done. If you have a monopoly, you can charge anything. But if you have certain competitors, you have to keep everything in mind, so that this Walmart says lowest price. They always guarantee our price is the lowest, even it is with 1 cent, but it is lowest. Come and buy. If you find anywhere means lesser price than us, then we will return. We will give you for free. That's what their policy is. That's on what they're thriving, right? This is price optimization, because I have worked with Walmart. That's why I'm telling you. They means all such kind of stores, they have systems in place where they have all their competitor data to see what is the price they are having. Okay, then you have inventory management. Inventory management, these all things are related to supply chain even. So inventory management, if my stock is getting out of inventory, I have to refill it as quick as possible, so that people don't come in and then I don't have stock. Certain retail marketing chains collapse because they're not able to foresee this thing. They are not able to balance the demand and supply curve. They are threatened by the bullwhip that effect that you are having. Then you have customer sentiment analysis. You will learn this in your machine learning module also about text analytics. In text analysis, how you are understanding the mindset about a product. Whenever a new company launches any new product, they understand what kind of people would be joining, people would be my target audience. What is the sentiment all across? What happened when Renault came up with Duster, right? At that point of time, Duster was sold so much because they were having the monopoly over there, since that was the first car being launched as a SUV in this budget range, and that's where Indian market it performed very well. Okay, and then they came along. Then many other cars, many other brand came out with. Now even one brand is coming with a SUV for Indian market in 6 lakhs rupees on road, right? That's pretty much low. It is like a hatchback car, but you are getting SUV in that. So these people are doing the analysis. What is the customer sentiment, what they want, and then they launch the product. So this data set have around 28 columns, which tells you about the customer ID. This is for a specific superstore sort of a thing. Okay, like you have in India, we have this Vijeta, Heritage, Spar, and Big Bazaar, and all that. They have their web stores as well. They have their physical stores also, right? Brick and mortar stores. For that, we have, and this is a store, or this is a supermarket, or a retail chain which is all across the world. So you have the customer ID, you have customer year birth, education, and all these things. I will show you in data dictionary, which would be more clear. ID, year of birth, education, marital status, income, what is the yearly household income. Definitely that is required to understand that what's the capability of a person to purchase, whether he is a premium customer or what kind of a customer. You can give a treatment accordingly. Kids at home, teens at home, date when you became enrolled as a customer with that superstore. Okay, then recency, number of days since customer last purchase, amount spent on wine in last 2 years. Similarly, for you have for meat, fruits, fish, sweet, gold, everything. Okay, you have deal purchase. This is on the discount, how many deals you have used. Web purchases, catalog purchase, number of store purchases. So these are the two main: store purchases and web purchase for the same person you are having. Number of visits, web visits per month. And these are the campaigns, the marketing campaigns that have been run. One, if the customer accepted the offer. Two, if the customer didn't accept the offer. These are my marketing campaigns. 5 different marketing campaigns are there. And this is your response. One, if customer accepted the offer in the last campaign, and 0 if not. Complaint, if customer raised the complaint in last 2 years. Country, which location it is. So I have around 28 variables, I think so. 28 variables are there. And not a big data set. Okay, this is around 2500, I think so. Yeah, 2240. That's the size of the data that we are having. You use your card to make the payment. It's not always in cash, right? You give something or the other. And suppose it's not for every customer, but you do this thing, and now all these store comes out, and they say that you take this membership card, right? And whenever you will, this is free of cost, and whenever you will purchase, you will get a 10% discount, or so on, so forth. Yeah, you never tell your income, but this is all that is captured from your credit card, from your banking. How do you guys think that all these unnecessary people, trading people, and all they call you up on your mobile? Why? They know that you would be interested and in trading. And to be very frank, see, you will see this pattern. Okay, yeah, they may know after phone pay, right? And many things are there. Okay, mobile data is also sold, transaction data is also sold. And one more thing, guys, just see this thing, see this pattern, observe this. Whenever you will have a salary hike, okay, 1 month passed or 2 months passed, you will start getting calls. And if it's a good salary hike, your income is really good, you will start getting calls from all these traders that are you trading and all this thing. Why that happens? Okay, that happens because all this data is there. Dharam, they say that they won't be selling your data. Of course, not every data is sold, but certain piece of data is sold in a specific manner. So everything is data, okay? And Google is always there, correct? There are many things. yes, bank still sell the data, not every data, but certain set of data is sold. And we fill so many forms in credit card and everything, and there is a last small thing with asterisk sign, terms and conditions applied. We never read that. Privacy is just a myth. All our UPI transactions are hacked, and that is how we are getting marketing calls. Correct. So this is all things happens over here. Okay, anyhow, let's go ahead. So this is the data that we have. Now let me go to, okay. So we are going to do exploratory data analysis, and this is on retail marketing. So first of all, suppose you are the marketing analyst and you have been told by the chief marketing officer that recent marketing campaigns have not been effective as they were expected to be. You need to analyze the data set to understand this problem and propose data driven solution. Okay, so let's get into this and see how we can do this thing. Yeah. Okay. So yes, guys, we will continue to discuss all these aspects. You guys are pretty much aware of it. Let's see how to use it as, or how to explore this as a data scientist. The very first step that we need to do is get a Jupyter notebooks ready. Means you have to import the libraries, at least the basic libraries. Rest you can do it on the floor, because you never know that what all you will require. So as a good practice, or as a generic practice, we always do this: NumPy, Pandas, Matplotlib, Seaborn. You guys are pretty much aware of this. Iter tools is for using enumerate for iterations that you have. And this is PLT. This is for Matplotlib only. RC params, I'm setting the parameters by default so that each time I don't have to set the figure size for each and every visualization to 12,8. You can overwrite it also by setting the figure size. That's perfectly fine, but I'm just setting it in one go over here. RC parameter, this is for the title size, and this is your grid, that how you want to see the grid, and what is your color palette that you want to see. These things are available on the Google. You can't remember these things. Remember, guys, these are color sets. You can just Google that what is the color palette for SNS, and you, whatever palette you want, you can use that. So these are all your basic setup that you need to do. Now, another thing I have done is suppress the warnings. It is good because otherwise your notebook looks very messy. That's why with the pink borders coming up, pink blocks coming in, that's why I'm putting it as ignore. Now, adjust the views. Maximum rows it will show you is 500, columns 500, width is 1000. Set the option, and this is just to expand the parameters and all this thing. You can totally remove this also. That's not something that you have to bother. These are just the aesthetics, which you put it, you change it. It is totally up to you. From here, the main journey starts. First, let's always a good practice to have a data dictionary in hand with you. Why this is required is because you don't know what customers' terminologies are. You would be going with your assumption, which might be correct, which might not be correct. So always go with the data dictionary. If you have data dictionary, means customer has provided, well and good. Otherwise, create a data dictionary, get a sign off from customer. I always tell this to each and every mentee of mine. This is how you should work. Otherwise, by the time you develop all model and everything, and last what happens is they tell you that no, how you understood this this variable as this is incorrect. Then you have to change everything. It's always a good practice to get a data dictionary. If not, then get a sign off over there. What if we have more than 100 columns? Still you have to do this. You have 100, 200, 400, 500, doesn't matter. You have to see the data. You have to see whether that column makes sense or not. What this is your analysis that you have to do, and that's what the pain area is. The data that I'm currently working in my organization, that is having 80 columns. We did this analysis. We asked customer, do you have the data dictionary? They said no, we haven't prepared any data dictionary. We went ahead and and did this analysis. That is known as, we provide data scorecard, in which one of the step is to create the data dictionary and check in this data scorecard, data dictionary, what the column means, how many null values it has, how many junk values it has, means all the percentage, what are the outliers, each and every column. And this is the scorecard. You will rate it and you will provide it to the customer, whether useful or not. There is a set format for data scorecard creation. That is the very first step that we do. Whether you are a data scientist or data analyst, you have to do this thing. how to create a data dictionary is nothing simple. This Excel file, na? What you have to do is go take all the columns, understand the data. It is done in Excel. Always remember, guys, needs to be prepared by data scientists. Can you share a sample of a data scorecard? Okay, I'll just create it over here quickly, just show you a glimpse of it. So one thing in data scorecard is this is the column name, then description, then you have whether it is null or not. Okay, sorry, it could be null or not, it is feasible or not. Then you have a data type. What is the data type of this column? How many missing values you have, how many outliers you are having, and based on all this thing you come up with your own parameters. That totally depends that, okay, this column is this much null. So suppose a column is 90% null, so its usability is very low. Out of 5, I will rank it just 1 or 0. Like that, you will have the data scorecard prepared. So this is the glimpse of it, that based on all these, so let's say ID column, this is like, looks like a redundant column to me because this would be unique, right? It won't be useful. So I can give a score. So accordingly, you will give a score to that column. I will give a score, usability score would be there. Usability score. Okay. Then you will have a clear data score. Like that, you have to, it totally depends on you how you define what all parameters. These are some of them that I have done. That's why I'm telling you more. So for usability, ID is not usable, I will give 0 to this. Clear data, yes, it has all the data is there, there's no missing value, I will give a 5 score on that. But usability parameter is there, then in this parameter you will give weightage and come up with the final score. Where do we get the description? This is by your understanding. If client has not provided, it is your understanding. What does this mean? From customer, you need to ask the client to describe the column. Yes, but Ragni, it not always happens that client would be able to do that. My client clearly said, I don't have it. You guys go ahead and create it and then share it across with us so that we can provide a sign off. That happens in most of the cases. When do we prepare this scorecard? Before starting the project. Once you get the data, once you're analyzing the first level of analysis, this is the first step that you will do. I think the client needs to sign the dict of that. Correct, Mayuri. That's what I mentioned. Is data score is similar to EDA? No, Nandini. Data score is not EDA. Data score is just first level basic analysis in your Excel. Guys, always remember, before jumping into Python, first level analysis always happen in Excel. With a sample, with a handful of data, if the data is huge, we will do first analysis in Excel. Yes, we use Excel only to create the scorecard. Okay, perfect. So I hope that you guys got a glimpse of it. Now let's proceed further. This is what my data looks like, what we have seen in Excel. Okay, so if we prepare data scorecard, no need of data dictionary. Data dictionary is part of data scorecard, Divya. That's what I showed you. Where are all the Excel analysis? What are all the Excel analysis done? See, what are the Excel analysis? If you have to find the create a pivot table, you can see a group by over there. You can filter out and see how many missing values are there. All these things you can do in Excel, right? These are basic. You can prepare some line charts and basic bar chart, column chart. All these things you can do. What are the other pre-analysis which happen in Excel before EDA? Yeah, that's what, Abhishek, I'm telling you. The pre-analysis, like how many columns are there, how many rows are there. I can create some pivot table. I can move my values here and there, do a group by, create some columns, check for the empty columns, check for apply some filter, check the values. In this case, how many countries, what are the values? Like if I go with this data, let's just suppose, so I will do a pivot table. Okay, I can do a pivot table, and then simple over here, I can take country as my rows. Okay, let's see at just the campaign. I'm just giving you a glimpse of it. Okay, these many people have accepted it. Okay, in Australia, 7 people have accepted. How many have accepted in, let's just sort options. So ascending, sorry, descending based on this. Okay, now see, SP stands for Spain. Spain has accepted most of your campaign. This is a basic analysis that you can do. Why don't we automate first level analysis in Jupyter rather than doing manual work outside? Just import data and all is automated. That is perfect. You are talking in terms of technical perspective. But when you do all these things in your Python, what happens is you can't take Python to a client, but still you can take Excel to client. Client is not a technical person. They are business. They want to see first level what you are doing. And for you to get into coding and all this thing, you have to understand the basic data and see if there are some gaps in the data, what you require and what is the analysis. This is an iterative process. It's not an assignment that you will do in 15 days and it would be done. So when data analysis is done in real world scenario, how do we perform the version control? We have Excel files, Jupyter notebook, may with question to that. Okay, so Eldohad, see, version control that you are not doing in Excel. Excel is just first level. Jupyter version control, definitely we do. We maintain things on client GitHub. Okay, that is one thing. And if you're in the cloud environment, like I have been working on Databricks Azure, over there clusters are there, automatically the versions are maintained for your Jupyter notebook. So these are the environment that you have. Excel film analysis. This is a very preliminary analysis that we do. Okay, so let's proceed. So this is what data we were having. Now this is just for the display and all. So head of the data, this is what you guys can see. Tail, you guys know this command, so I won't be spending time. So you guys know this command shape. There's one more command, size. Can anybody tell me what is the size command? Let's figure out that which are the ones. Yeah, person is greater than 100 years old, right? So it's a wrong year. So I'm figuring out what are the rows which are less than 1900. There are 3 rows only. Why to bang your head? Just go ahead and drop it. Now it's very small, so I will go ahead and drop it. Done. And then this is one thing that I did. Still I have not treated the date column. Okay, still I have not treated the date customer column. We can replace 1900 with, you can do that, but these are very small. That's why I did this thing to select, to drop these rows. Okay, you can do that, Ayushi. That's perfectly fine. There is no hard and fast. These are just 2 options that you have. Okay, fine. So now how I created the function for numeric column, same way I'm creating the function for my categorical columns also, to have the count plot, the frequency distribution for my categorical column. All these columns I have considered over here, and then I'm doing the analysis. Okay, yeah. So these, if you see, all categorical columns have been listed down over here with their unique counts. Okay, and also their count plot. So in one go, you are able to capture anything. One of the person who is more than 100 years old is single, right? So data transformation. Now what I'm going to do is fill my income value with median, as I told you. So that's what I'm filling over here with median value. Go ahead, you guys know this thing, how to fill the median value. This is who have not covered this thing, don't worry, it would be covered in advanced statistics in EDA. In your second mentoring session, second week, it would be covered. People who have been doing machine learning till now, they would be well versed with this thing. Okay, so all these are treated. Now you see there are no null values. We are good, we are happy. Now comes the date customer column. Okay, see, what is the data type? It is object, correct? This is object that is listed down over here. And now the count became 2237 because we have dropped 3 rows, right? Okay, next what? I'm converting. Yes, it is slash. It is the problem is the format. That's why it is not considering it. So what I will do is, using pandas, we will do PD to date time, this column, and again store it back over there. You can use in place also. So done. Now see the format. The values is still the same, but it is with dash in that. Okay, this is the standard date format. In the US format, that is your year and then your month and date. Okay, this is the standard format we have. Yes, YYMMDT, correct. Fine. So done. All the columns are treated. Everybody is good till now. Why did we didn't drop another 3 columns? We dropped 3 rows because those values, the age, I dropped 3 rows where the age was greater than 1900. Okay, the year was greater than 1900. That's why I dropped it. Okay. Now what to do next? We can derive new values, but let's see some interaction first. So what is the interaction? We should have corrected the data where we drop. But see, everything, I'm not saying, I'm never in favor of dropping it. If it is a big value, it is just 3 data points. So 3 divided by 2240. What is the percentage, guys? 0.1%. It is very, very less. That's why I did go ahead and drop it. Otherwise, I am also never in favor of dropping it. Why you want to bang your head when things are so simple, right? So you have to take a call. Okay, this is a judgmental call that you have to take. Everything is not treatable. Fine. So now, few interaction. You guys know this thing. This is basic understanding, logical understanding that education and income would be related. So let's see first interaction. So when people ask me while doing data visualization, how will I know which column I have to see the visualization? You have to apply your logic. What do you think based on a data dictionary that these columns would be linked or this column might be interactive and all this thing? That's where you go ahead and use those column in your interaction. In what all scenarios we need to create function? Please explain above function how to write. Okay, above function as in you want this function, Ravi, how to write this function? Okay, let me walk you through. See, there are two things. One is a loop and second is a function. These are your iterative things to remove the redundancy. When you are working on PCA, when you will learn PCA, I don't know whether you have covered or not, you have too many columns over there. You can't keep on doing it for everything. Even the for loop also you have to write multiple times. What I'm saying is generalize things. That's where I write the function. So whenever you are writing the function, you have to give a name and how you will give the input. So this is your input. When you will be called that function, you will give it as an input. Now what you want to see as part of that function, this is, I want print details of this column. It will automatically take. Then this is a static thing, a line. Then column, what are the value counts, print that. Then create a figure. In that figure, what I want to see, a bar chart. Normal commands are there, but I have written it in a function. That's the only thing. And for everything over there, you will define a column. For the column, you will write that function. I have passed a value which I will pass in while calling this function. That's it. Okay. Ma'am, there's always one confusion, either to treat the year column as numeric or categorical. How would we decide? Okay. So first of all, guys, there is nothing as numeric or categorical. There's categorical or continuous. A numeric column can be categorical, also can be continuous also. So question should be, it is continuous or it is categorical. The very first thing is that if you can perform mathematical calculation, arithmetic calculation on any column, which is meaningful, which has meaning in that, then it should be a continuous column. If I talk about year, 2008 plus 2009, it will come as 2017. Can I make it? It is sensible? No, it is not sensible. It is totally illogical. Okay. Can we plot heat map first and identify correlations from them? Yes, you can do that. But again, there are many ways. There are many ways to do the same thing. I will show you a different way to do a correlation today. Okay, how you can see that thing. With use of box plot comparison or two variables, will use box plot for comparison or scatter plot. If two are numerical variables, I mean to say continuous variables, that you will use scatter plot. If one is categorical, one is continuous, then you should go as box plot. Okay. If both are continuous, then scatter plot. Okay. We can convert it to age, current. Yes, we will do the thing. Ma'am, what to do when there are multiple ID columns? If that is not useful, you have to first check whether that ID is useful or not. Go ahead and drop it. ID columns generally don't add value, but just don't go by my word. It depends on client data, what you are working with. Can we find average of two columns which has DD? No, you can't find the average of two columns which have DD, Why? These has date column, right? Why you want to find an average? That again, this is date. You should not perform such functions on that. Can you repeat about continuous and categorical? Okay, Sumit, so what I was saying is any column which is numerical on which you can perform mathematical calculation and it is useful, then only it is continuous. If it is not, then it should be categorical. Whether it is number or not, it doesn't matter. So taking year into consideration, 2008 plus 2000 ordering date and delivery date. Say to find delay. Yes, you can do that thing. We will come around with the age column. I will show you that thing, Balaji. Hang on for a while. Year column is there, 2008, 2009. So what I did is, so I am creating a customer age column. When the customer enrolled minus the birth year. Now these are the date columns. I am taking from this only the year because this is complete date. So I will take only the year from here and birth year and just subtracting it. I will get the age, and I'm plotting a histogram for you guys over here. So you can see this is how the visualization is coming. Most of the people are ranging, another view we can say, people are ranging between 40 to 45 or so, right? Right, second attempt or night schooling or something like that. Correct. So now I'm plotting the same plot again with country, customer age, and education over here. Okay, the same plot. But I have removed that income over here. I am plotting customer age. So what you can see, second cycle is this purple one, right? People are generally in the age range of 35. There's this, even some 20s, I can say, right? First cycle is bachelor, second cycle is master, third cycle is doctorate. That is what is the understanding. But over here, you have PhD separately, you have graduate separately. So what we can do is, see, I took year over here. From here, if you write month, it will take month. If you mention date, it will take date from here. Okay, so what it could be, if you see, it is on the lower range also. What my understanding, it would differ. What you have to go back to client and confirm this thing. But what my understanding looks like, it is more of people who are in their undergrad or they have not completed their undergraduation, because these are the people who are on the lower side also as well on the higher side also. Same year for every customer, so customer age will not be calculated on same year for every customer. No, it won't be on the same year. It is from customer I am taking the year and then subtracting the year birth. So for that specific customer, when he enrolled and that thing. We can have perception while doing analysis, dropped out or later continued. So that perception is always there. Your data science works on a lot of assumption. That's what we are trying to do over here. Okay, so what I did is, mostly the age range for second cycle educated customers is from mid 20 to 50 years. It more or less could fall in category as people are in undergrad or haven't completed it. Okay, so now let's say the marital status. These are just, you are clearing your data. Marital status, you can see YOLO, alone, absurd, single, divorced. I can mark everything under single, right? And married and together, I can mark it as together. That's what I did. Now I told you a global function. This is your temporary function or local function that would be only executable for this cell, not in your complete notebook, only this cell. How can we conclude that about education? Because even basics are in the wide range. Again, I'm saying this is my assumption. Your assumption can be different also. I'm saying that already basic education is, see, on a very low level. We understand that the salary, we saw the relation between education and income over there also. And what happened is, people with basic education are having less. So I can't say that this is undergrad or something, but this is expanding in a span and people are having good income also. So might be people would be undergrad or they would have left like that. Okay. Yeah. So local function is lambda. What we are doing is, for this column, I want to apply function lambda on x. X means each and every value of this marital status for each and every row, it would be considered as x. So find it in this string. If it is YOLO, alone, absurd, divorced, widow, whatever is it, fill it with single, else leave it wherever it is, means however it is, leave it like this. Like, you will learn this thing later also in your course if you have not completed, but this is, and you will use it quite often, but this is local function that you have. So now if you see, married are more, together also, the single also, I will combine this married and together again. I can combine this thing, and that's what I did. Now you see, people who are couple, they are mostly the customers, correct? We can replace also. Yes, you can do that also. See, guys, there are many ways to do one thing. But again, this all comes with practice. This is a good coding, standard coding practice that I am telling you. You can use replace also. But as a from the industry perspective, I won't prefer doing that. Okay, because that doesn't look that very nice. So data transformation is means all these things we did. Now I will do some data transformation. I want to see what is the purchase, what is the spend. And as I have shown you this data dictionary over here, you guys could see, right? This wherever M and T is written, this is an amount, right? Wherever purchase is written, it is the number of purchase. So I can combine based on the name of the column and get the total. That's what I am doing. So from this column, wherever purchase is there in the name, in the string, combine all this. I'm removing the deals. That discount thing I don't want to check. I want to see what are the purchases. I am combining that, getting a sum of it for each and creating a new column. Same thing I'm doing for MNT. Wherever MNT is there, I'm getting a sum of it. Okay. What is the difference in apply and apply map function? Apply is for one row or the column wise, and apply map is for each and every element in that data frame or in that array. That's the difference. Okay. So done. Now, if you see, I have two more columns created. Number of total purchases, total amount spent. I got combining all the purchases for this row and all the spent for this one. That's where my numbers are there. So this is the transformation that you have to do. Okay. This is my data frame that I have created, ABC. Okay. Now what I'm going to do is I'm defining a function and I'm just applying it over here. So what I'm doing is I'm saying take the row, take the sum of the row, and just I will apply it over here. If you will see now, what it has done is it is giving me NaN. Since I'm applying it to row, so it is giving me NaN. What it should do, it will just add it, and it I don't know why this is coming, but a new column has been created. There might be some error that I have done, but anyhow. So this is the row that is coming, a custom function I have written, and it will apply it to each and every row. Okay, 1, 10, 20. It will add it and it will give you the number over here. There's some error, that's why it is not coming the value, but a new column is created. Now, when I will apply map in, I have, okay, that's the problem. Just a minute. I have not imported that. Okay. Now, if you see each and every element, it has been applied. So apply map applies to each and every element, and apply map is only for your column or row wise. Okay. That's the difference. Clear, guys? Is there relevance of letter used in this code? We use C. No, that's any name you can give. That doesn't matter. Okay, that doesn't matter. You can use C, you can use call, anything you can give. That is to your understanding. Okay. Okay. Chalo, let's have a relationship between total purchase and income. This is what I can see. There is some relationship. I created a pair plot also, which is not readable at all since I have a lot of columns. So let's ditch this and proceed further. You guys have done correlation till this part. You have done correlation till this part, right? This is how you know how to do the correlation, right? Now, what I'm saying, from this correlation, I want to see a correlation of my purchase with all the only of purchase. So what I'm doing is from this correlation, pick only number of total purchases. So see, all the columns related to number of total purchases will show you. I don't want the subset also, Tushar. From this correlation, I'm taking a subset. If you're saying that, yes, correct, but I'm not creating a correlation on a subset. So I'm having my correlation for all the columns only for my total purchases now. Okay, I can see that it is highly correlated with your income. Okay, can we describe only for two columns? Yes, you can do that also. I'll show you. I have done that even. So all these things I have done already. So you can see it is highly correlated with amount spent. It is highly correlated with income. Many other columns, it is negatively highly correlated with kids at home. Not at least moderately, but on a verge of high correlation, right? So all these things we can see. Now, I am saying, I know it is related to income. So I created a line plot over here with income and total purchase. See, it is increasing. That's what we were seeing. How to find all having more than some condition. You can create a data frame and then use it, right? As you find the condition over there, that also you can do. Okay. Total spend, total purchases, as the spend increases, total purchases increasing is high. So this is also highly correlated. Kids home, it is negatively correlated. You can see. So more the number of dependents, more less the purchase amount or less the purchases are. That's what we can see over here. Okay, the correlation is column wise, but generally we use correlation for two columns, right? Correct. That's what I'm saying. See, column wise, but what? Okay, let me do this again for you. This is what you get. It is ID to ID, ID to year of birth. That's what I'm saying. I don't want to see ID correlation with year, birth, income, and all this. Only pick the correlation with total purchases. It is again a correlation between two columns only: ID, total purchase, year of birth, total purchase, like that. But I'm not seeing the complete matrix. I'm just seeing one column wise. Okay, fine. So this is done. Now I am creating a pivot table. Pivot table I'm creating where I'm using country as my index column. Okay. Then the values would be total number, and I want its two aggregation. One is the sum and the second is the mean. So this is what I have. What I can see is the most purchase is happening from Spain, but the mean is still low. Mean is high for Mexico, right? ME stands for Mexico over here. It is mean is high, but the purchase is very low. Total purchase is very low. Might be only few rows. That's why the mean is getting skewed over there. I can leave this, right? I'm not bothered about this. My concentration should be more on Spain. And then you say India is also there with less purchase and a less mean, or I would say the lowest mean is there for India. Okay. So this is just for my sake. You find correlation of one column with multiple columns taking one at a time. No, this is as per my convenience, what I want to see. That matrix view is confusing. I don't want so much information. What I want is I'm based out only in total number of purchases. My area of concern is this. I want to see a relationship with other columns also. That's what I did. How it is dependent on the store purchase, web purchase, and that's where I'm taking the total number of purchases. This is what simple subset, and then I'm taking a correlation and I'm seeing only its correlation with this. I don't want to see the complete correlation matrix. This is a view. This is how you can view your data instead of getting into confusion. Okay, now if you see what we can see, both web purchase and store purchase are highly correlated with total purchase, but the store purchase is more correlated than compared to web purchase. Can I conclude this thing that people are preferring a store purchase over web purchase? Yes. Okay. Now what I have done is I have seen a correlation of all the columns with total web purchase and number purchase. Why I have done this thing? I could have taken each and every product also. If you see, I want to see the amount. So if you see amount on wines is highly correlated with the store purchase compared to web purchase. Same goes for fruit, same goes for meat, same goes for fish, for sweets. So I can say perishable products are more purchased at a store compared to gold. Gold has a high means both a moderate but higher side on web purchase compared to your store side. So I can say perishable goods are more purchased in store. This is easy for you to relate things. If you see the complete matrix, it is very confusing. Okay. So that's what I did is now I took all these columns only and I have added a new thing over here. This is like your conditional formatting that you do in Excel. Over here, you have a style background gradient without creating the heat map. I have nowhere created the heat map. I am getting this thing. Can we plot graph using correlation? Yes, you can plot graph Rolly. That is your heat map. This is what I am doing, a conditional formatting over here. Okay. So it will color code based on the correlation in like it does in heat map, but without creating the heat map. Okay. Same thing what I showed you above, only for few of the columns that I took all the products and with total spend. So if you see, most of the people are spending money on wine, followed by meat, right? What is the condition here? Okay, style background gradient, light palette. This will automatically take whatever is the amount. So whichever is the highest value, it would be dark color, and then the color will decrease like you have in your heat map most of the times. Okay, this is, yes, it is the inbuilt functionality of SMS. Okay, fine. So I can see wine is being most spent, followed by the meat product. Okay, now let's do a campaign analysis over here. So what I'm doing in campaign analysis is all the campaigns I took, okay, and just plotted a bar plot. This is what I can see. So what is this? I can see that campaign 2 is least and campaign 4 is most, right? It is accepted most by the people, right? So what I calculated over here is I calculated a success. What means I'm it's not the success actually, it should be accepted over here. It is accepted. How much is accepted? So I'm calling it, you can define it as success only. It is the total sum that I'm seeing. So these are the numbers that you can see. Campaign 2 is least accepted and campaign 4 is most accepted. 3 and 5 are also almost on the same lines, right? Okay, now what I'm doing is I am going to do a chi-square test. So chi-square test is a non-parametric test. I'm doing it only for one of the campaigns to see that if it is based out on the country that I am having. Is it relevant to the country? Is it dependent on the country, the acceptance rate? So what I did is I created a cross tab for 0 and 1 accepted, not accepted based on the country. Okay, this is a simple cross tab you guys know of. Psych by stats library that we know, and chi-square, P, DOF, expected, all these things. Chi-square contingency, cross tab table you can give and just print the P value. P value is 0.40. When P is high, null will fly, right? Null will fly means we are failing to reject the null hypothesis. What was the null hypothesis over there? That acceptance rate of campaign 4 is dependent on country. And what is your alternate hypothesis? Sorry, it is not dependent on country. And what is your alternate hypothesis? That it is dependent on country. Thus, since we fail to reject the null hypothesis, it is not dependent on country. Correct? That's what we are saying, to check the dependency of the column over other category. Correct. So campaign 4 is not dependent. This is my first level of conclusion that I can say. We can definitely drill down further on this, which we will do in next session. But what is the takeaway for today? Total purchase is highly correlated with the income and total spend. Total purchase reduces as the number of dependents increases. Most of the customers are couple. Store purchase is more than web purchase. Perishable items are purchased more at store than through web. Campaign 2 has performed the worst and campaign 4 has performed the best. Campaign performance is irrespective of country. What is this over here? You won't be having equal to or not equal to in categorical, non-parametric. It is that it is following that assumption or it is not following that assumption. So null hypothesis says that it is not dependent on country, and alternate hypothesis says it is dependent on country. This session or the series that we had, or industry session, it was on retail. Okay, it was on retail marketing. And what we covered last time is that what are the top-notch case studies that we have in retail marketing, and these are few of them listed on the screen: recommendation system, personalized marketing, price optimization, inventory management, and customer sentiment analysis. We were trying to solve a case study or to see a case study where we said that we will do an exploratory data analysis to find out that which campaign worked well, which campaign didn't work well, how a digital marketer can decide that what is the target audience, whether the store purchase is more, whether the web purchase is more, which country is responding better, what is their target audience, all these things. We went through some of the parts. We did first round of EDA where we concluded some of the cases. Today, what I will do is I will do some more hypothesis testing and introduce new concepts over here. You guys would have heard the word, but might have not used it. So that's what I will show you today over here. So it's more of a extended learning from whatever you have completed in your course till now. And the rest part definitely you might be knowing, but today's session is 85% new learning. So be attentive and listen. Great. So as usual, we are importing some of the libraries. So, this is the first part that we imported libraries. Then we did some of the rudimentary hands-on part to check the describe and all that. This is the dictionary. Let me show you the data set, what it contains, the data set. This is how the data set looks like. It has around 31 columns, I believe, and or more than that might be. It has 28 columns. Okay, it has 28 columns, and you have ID, year, birth, education, different categorical columns, date columns, and numerical columns. That is the continuous column. So if you see, data dictionary is also provided. And then we went ahead, did head, tail, describe, dimension, check the size, everything we check. Then info told us that there is an error there is a correction required in income. You have missing values only in income column, and also it is marked as object, so we have to correct it, since it should be numeric, so that I would say it should be continuous, so that you can do some arithmetic calculations also. And along with that, if you see DT customer, this is marked as object. This is a date column, thus it should have been converted into date. So that's all our assumptions mentioned over here. Then we looked at missing no library. So missing no is basically to see a visualization aspect of missing values in each and every column. So wherever you can see a white line, because since your income column is only having missing values, that's why only over here you can see these horizontal white lines. It means you have a missing value. Okay, then we calculated the percentage of the missing values. It is since income is having very low percentage of missing values, and we saw that there are outliers, thus we went ahead and treated it with median, which I will treat it later. Over here I corrected income space thing. I corrected missing no is not getting imported. It might not be installed for you. Try and installing it. Okay, it has to be installed. Correct Soham, it has to be installed in Jupyter Notebook first. You have to use the pip command to install that. For me it is installed, that's why I'm just importing it. Okay. Okay, so now why it was object? It was object because of this dollar sign and this comma. So we have replaced this with a space, and it was converted it into float. So now if you see, income is a float column, and that space thing also I have changed, or I have replaced over here. Okay, that space is also gone. Now we wrote a function to have in one go for continuous column, to have in one go the description of each and every column, followed by its distribution, that is the dist plot, and its box plot. So all the things were coming up. This is still running. Let it run. It will take some time. Okay, so all these things were coming up. Now this is done. After this, what we have to do, I told you another way also to look. This is one way to look at different graphs in one go. This is telling you the description, then dist plot, then box plot, then again for the second variable, description, dist plot, box plot, so on and so forth. But over here also, if you see, what is this? These are different box plots are there. If you see for accepted campaign, these are numeric columns, but it is coming just as one dot and one line, because this is 0 and 1. This is actually an object column. So what we should do is we should remove these columns. This is not a continuous. We should remove this column. And also ID column is a unique one. So we can remove this, and we can go ahead with all the different box plot. That's what I have done. You can see different box plot being created for each one of them. Now, what is your insight? Insight is a few of the insights that I have noted down. Year of birth. You are having some problem over here. It is showing you the minimum value as less than 1900. That might be something systematic error. The data entry error would be there. So we need to correct that. There are 3 rows which are there. Only 3 rows are there. I'm again saying this thing, you can treat it also, but since it is very small number, then I chose to drop it. Ideally, you should not, but if it is small 1, 2 rows, you can go ahead and drop it. So I just went ahead and dropped these rows. Then this is the function that I have created for the univariate analysis of categorical column. Okay. And same way, you can see the describe and the categorical column, all your count plots. Data transformation. Now, what I said is income value was having missing values, right? Income column was having missing values. I treated it with median because I know that there are outliers, and since it is just 1%, I didn't want to have the segregation done and think about any other method to treat it. I can go ahead and treat with the median. That's what I did. I have removed all the missing values. Now, no column is having missing values. Date customer column, DT customer column. This is the format. In Python, the default format for the column to be considered as date is segregated by dash instead of hash. So from pandas library, you can import, you can use to date time and convert it into date. Now this is converted into date format. Okay, this is a date time. Okay, so now what's next? I derived, let's see the interactions first, and then I derived few of the columns. So this is the interaction between education and income. If you see basic is on a very low side, then we can say the income for the people who have basic education is on a very low side, then we can say that these are like bare minimum educated people, right? That's why they are having a low salary as well. Same thing I did for country, income, education. These are different box plots that you can see. Okay. And then we went ahead, did some again dist plot and all these things. What I did is I calculated the age of the customer. Age of the customer is based on when the year of birth of the customer and year from date DT customer. When it is converted to date time, you can directly refer year from there. Okay, just normal query. Do we need to treat data for outliers if we wanted to do PCA for this data set? So this is done. Now I plotted the chart based on country, customer age, and education. So these are different plots that you are seeing over here. Most of the age range for the second cycle. There's something as education as second cycle. Most of the people are between 20 to 50 as my assumption. This is based on your assumption. Somebody said that we can take it as other part of some other education also. That is perfectly fine. That is totally your understanding. I might be wrong, you might be correct, you might be wrong, I might be correct. That totally depends. So this is an iterative thing that you have to see. It's more or else could fall in category as people are undergrad or haven't completed it. We can say that thing, right? Because their income is also low. How to write the insight? Okay. So see this? This is how you can write the insight. Division color, alert, block, info, automatically it will give you the color, and style is this Georgia font style. And that's how you can write. So you will have my notebook. You can just click and copy paste and get used to this writing insights in color. You can even have something you can write in red color also. That is alert or something like that. Okay, so this is the count plot for marital status. We saw that many people are alone. We can combine it in single, and married and together can also be combined in together. So first I combined the singles, then married and together, but then I also combine married and together. So this is what your distribution looks like, single and together, or couple, you can say. Okay, transformation. What we have is we have few columns. Let me show you these columns. There are some columns which are starting with the name, with the title or the prefix as MNT. These MNT, all these MNTs are your amount spent on that specific product in the last 2 years. And we call, when this is the purchase, this is the total purchase, number of purchase. Anything which is ending with purchase, it is the total purchase that you are having. So with that, I created a column over here, 2 columns. One is all purchase I combined and all amount I combined, and created 2 columns, which is amount spent and total purchase. And then we were seeing the interaction with the income, created the pair plot since many columns are there. So you won't be able to see. We went ahead with correlation. Okay, this is the correlation that you are having. Number of total purchases that you have over here. I'm seeing the correlation of just 1 column. Okay, all the columns, but I want to see only with respect to total number of purchases. That's what we are seeing. How you combine, can you please explain again? So purchase column, how I combined is C for C in market column. So each column is referred as C. You can give any name. You can give COL also. You can give COLM also. Anything you can give. If purchase, if the string contains purchase, then, and I'm removing this number of deals purchased because that was the discount. So all that, I'm naming it as a new column, number of total purchase, and wherever you have this string, it will combine it in purchase features, that column, and give a sum for that. So all the columns which have purchase in that, it will just sum it up. Same goes for the amount. Wherever the string in that column has amount, it is taking all the columns, creating a list out of it. If you want to see, let me show you this thing quickly. See, this is the list of all the columns. So what I did is I first created a list of all the columns, and then I'm just adding that column to have a new column as amounts, total amounts spent. So let's proceed. So what I'm doing is, if you see the correlation, normal correlation, let me just remove this. If you will get this way, but I want to see correlation of all the columns. From this, I want to only pick. Why are you removing? I'm not removing anything. Okay, you are saying this discount purchase, this one, this is just the discount one. I don't want to see how many deals are purchased in discount. That's why for my analysis, I removed it. You can consider it also. There is no hard and fast. That again, this is an iterative process. It depends on your business understanding. Yeah, so if you see, this is telling you the complete correlation, right? Now, I want the correlation of all these columns only with my value, that is total purchase. That's what you are seeing, different correlation. Now, what I did is, if you see over here, this variable is highly correlated with amount spent, this one, and income. And it is negatively, almost moderately on a verge of moderate and high correlation with kids at home, right? So means number of dependents, something like that. So I drew a line graph based on your total number of purchases and income, then total amount spent and total purchases, your kids at home. So if you see, this is a negative correlation. Okay. Now, what next? I created a pivot table over here. Pivot table of country and total purchases, sum and mean. This is what I am having, the sum and mean. What I could see over here is, again, what I could see over here is ME, that is Mexico, is having the total purchases less, and your number of your mean, the average purchase is high, but actually the purchase is very low in ME. If you will check the data, it is only 3 or 4 lows only. That doesn't make any sense, because might be people are purchasing, only 3 or 4 people purchase and they purchased a lot over there. That doesn't make sense. It won't add value to the other analysis over here. So that's why I'm not considering ME. You will see later in many of the analysis. Okay, can we sort this correlated data? Yes, you can definitely sort it. You can go ahead and store it in a data frame and go ahead and sort it. That's not a problem. As usual, you do a sorting, you can go ahead and do that. Okay, everything you can do with your data until unless the syntax is correct. Then again, I'm taking the market DF based on different type of purchase, store purchase, web purchase, total purchase. I'm taking the total purchase, how it is correlated. If you see, this total purchase is more, means it is highly correlated with both, but it is on a higher side with the store purchase than compared to the web purchase. Okay. Okay, Durga, I'll explain about the aggregate function also. So aggregate function, when you are doing a pivot table, you aggregate function, what it will do, what value you can see. So what it will do over here is, it will index this country. Okay. So this is what index value is coming over here. Then what I see, I want to see the values of number of total purchases. These values are from number of total purchase. And I want to aggregate it on 2 levels. What are those 2 levels? I want a sum of this. I want a mean of this. So for each and every country, it is like a group by. I'm grouping on different country, and what I'm grouping, it is like your Excel pivot table only, right? That you are having different countries, and then you are dropping number of total purchase in the value. So it will give you the sum, and if you change to average, it will give you the mean. That's what I'm doing over here. That's the aggregate function will do. Okay, let's proceed further. What I did over here is, you guys have seen this a lot now. Now what next? I did a color coding. This is nothing but this is something like a conditional formatting that you have in Excel. It is not a heat map. It is a conditional formatting, but it takes on the same way, higher the value, higher the color code, lower the value, lower the color code. You can get the color code easily. So all these variables I took, that is with amount, and I took a correlation with total is spent over here. Style background gradient. This is the light color. This is the code for green. CMAP is equals to true to give you the color coding over here. That's what I'm seeing. So map, color mapping. This is CMAP is nothing but the color mapping that you have. If you see, then wines is highly correlated with total amount spent, means people are spending more on wine, followed by the meat product, and then your fish product and all these things. Okay. Then I did a campaign analysis. You can do this analysis for other products also, the other columns also. Then I went ahead and did a campaign analysis. There are different campaigns, campaign 1, 2, 3, 4, 5. So now what I did is, I just saw that which campaign is more valued or more accepted. It is campaign 4. Campaign 3 and 5 are something at par with that. Campaign 2 is the lowest, and campaign 1 is in middle of that. So this is what the numbers are. Campaign 4 has been accepted the most. I created a cross tab table. Why I want created a cross tab table? Because I am going to perform a chi-square test. Ma'am, you have given only one color code, but there are two colors in the CMAP list. No, there are no two colors. There is only one color. These are shades of green. So CMAP means color map. It will map the color with the value, the different shades it will take. That's how CMAP works. So now over here, what I'm going to do, I'm going to perform a chi-square test. And what does this chi-square test gives you is, chi-square test, I have a null hypothesis to see that campaign 4 is country specific. And that's your alternate hypothesis. And what's your null hypothesis? Null hypothesis says that campaign 4 is irrespective of country. So that's why I created a cross tab table. Then using chi contingency test, I am doing this cross tab part to get the p-value. P-value is 0.4, which is higher than 0.05. Thus, I fail to reject my null hypothesis, which means that campaign 4 is not dependent on country. Clear? So chi-square test, I have a null hypothesis which says that campaign 4 is independent of different countries. It is independent of country it is running in. And the alternate hypothesis says it is dependent on the country. So we are doing chi-square test because it is categorical, it is non-parametric test, and it is a goodness of fit test. So what I'm seeing is that whether campaign 4 is dependent on country or not. So I did the test and figured out that the p-value is coming greater than 0.05. Thus, I am failing to reject my null hypothesis. Now, what was the first level of conclusion? Total purchase is highly correlated with income and total spent. We saw total purchase reduces as the number of dependent increases. Most of the customers are coupled. The store purchase is more than the web purchase. Perishable items are purchased more at store than through web. That also we did a correlation analysis. Campaign 2 has performed the worst and campaign 4 has performed the best. Campaign performance is irrespective of country. This was the first level of conclusion that we did. While one is doing the analysis of data for any problem, is it a specific question are defined by the client and data scientist has to answer based on the analysis, or we as data scientists need to define questions. Client will never give you questions. It's not an assignment. Client will just tell you, this is my problem. I want to increase my sales. Tell me how you have to increase. While you are doing the EDA, you will find out different things, different ways you will do it. You will go back to customer and tell that this is what you have found out, or this is what you have not found out, or this looks correct, this looks incorrect, all these things. This is up to you. Client doesn't know data science. Client just know business. Client just know what they want. That's it. Rest is up to you. Is it clear? What I'm going to do today? We will start to see how the customer look like. Means for this data, for this retail chain, what are their customers basically? Let's do that analysis. Now, why that analysis is required? Can anybody tell me why you need to know who your customer is? To increase the sales, okay. To design the campaign, for focus strategy, better targeting, to plan my campaign, to understand the customer, correct. You should know whom you have to target, where you personalize marketing, where you have to put in your money, what should be your set of target audience. People who are in digital marketing, they would be knowing this thing, that whenever you are putting in money on social media or any other digital marketing platform, you have a certain CTA defined over here. You have to define your audience and everything. As you increase the reach of the audience, your budget also increases. So more the widespread it is, you would have a huge budget, but your amount will lower down. Your number of customers might lower down. So what I want is, I want to have a target set of audience so that I'm not wasting my money also, and I get the right set of people who are my customers. So that's why it is very important to understand that who your customer is. More defined domain knowledge and clear targets. Yes, this shit up. So what I'm going to do over here is, I created a pivot table again on country, total amount spent. Columns is marital status. Okay. Column wise, I want to see marital status, this thing. Okay, and then mean, I'm calculating the mean of total amount spent. What's the average amount spent? Naming the columns as your single and together. And then I'm just doing a transpose. That's why you are seeing it like this. So this is the output that you have. Different countries and single and together, since I have named only two now. And these are the average that you have. What you can see from here, almost it looks like that single and together both are spending same amount all across the different countries, where US is topping the list for single, and if I go for together or the couples, then it is your Canada is topping that list. But almost it is like 50-50 for single and together when you are talking about the spend. More defined, okay, yeah, fine. So I created a pie chart over here. You guys have learned how to create the pie chart in your first module, that is Python for data science in data visualization. That was your third module or the third mentoring session that you guys would have learned over there. So what I'm doing is I'm creating the subplot based on these different countries I want. So how many plots I want? 1, 2, 3, 4, 5, 6, 7. 7 countries are there because I have dropped Mexico. Otherwise it would be 8 countries. So over there, because I have only 3 rows, that's why I dropped Mexico from there. It is not adding much value. I created the subplot, that's the size 4 to 1 would be empty over there. And then I'm iterating over the different rows that you have. For each and every row, I'm iterating and creating the plot. So what is the percentage? What is the row value divided by the sum of the true value? And that's how, and I'm just doing an explode of 10%. Okay, so this is how your pie chart looks like. Different pie charts you are having in one go. What it is telling you is that if you see all the numbers, approximately, as we saw, 50-50, something equal amount of distribution is there. So that's what, I don't have much to say that who are my actual customers, single or together, single or couple, both are spending equally. So I can target both. Might be that in my initial data itself, where I have not combined single and together, I have kept married, YOLO, absurd, divorced, so many are there. We can target, we can see that way also. Then we can target more in single, who are the people I should target? In together, who are the people I should target? Okay. Now the other part that I have over here is same analysis I have done for education level. Same thing on different education degree. Same pie chart I have created. These are your different pie charts that is created now. These are your different pie charts that you have over here. What is this pie chart telling you? This pie chart is telling you, if you look over here, of course, the part which is great, it will explode by 10%. It will be taken out over here. Australia and South Africa. Australia is having PhD. South Africa is, where's South Africa? This one. South Africa is having masters. Rest all of the things are having undergraduate as the exploded part. Means their target audience for the rest of the countries is mainly undergrads, and for Australia, it is PhD people, and for South Africa, it is masters people. So when you are running a campaign in South Africa, you should target more of people who have done masters. And for Australia, you should target more of the people who have done PhD. And rest of the countries, it is the undergrads that you have to target. That's what we can analyze or we can see from here. So the target audience is pretty much balanced in terms of marital status. But apart from Australia and South Africa, rest all countries have undergraduate spending the most amount. Now, I'll show you something else also, and then we will get into other hypothesis tests. First thing is, what I did is I did a group by based on country and took a number of total purchases. And over here, I total purchase and total spend. Both I took and created a bar chart over here. This is what you are seeing. This is the total number of purchase. Spain is highest. Total amount spent, that is also the Spain is highest. Now, if we look around, what does this tell you is, first thing, of course, Spain has highest spent as well as highest purchase compared to the rest of the world. We know that purchase is directly proportional, or purchase is highly correlated with spend, and vice versa. Thus, this observation is very obvious that if you will have the high purchase in one country, that same country would be spending also high. Everybody agrees to this observation? I'm relating to the previous correlation that we checked. So we can perform 2 sample t-tests to see that the mean purchase by Spain is different or greater than the rest of the world, because rest of the world is very small. That's why I'm combining it as rest of the countries are very small. That's why I'm combining it as rest of the world, and Spain I am taking as single. So this is a 2 sample t-test that we are going to perform. You would have said that why we are not performing ANOVA. Perfect. You can go ahead and perform ANOVA also. But you see, Yes, these are independent samples, Mehul, because this is from different countries. So they are totally independent. That's why this is not a pair t-test. It would be two sample t-tests. Clear? And I'm not doing ANOVA because these numbers are very small. Thus, I'm combining it as rest of the world and going with Spain. Okay. So this is a two sample test. First, I did a group by mean sort. These are the means. Just have a look of this. This is the means of different countries that you have in terms of total purchase. What is my null hypothesis? Can anybody define my null hypothesis and alternate hypothesis over here, please? Mean is equal, right? Mean of some total purchase is equal for Spain and rest of the world, and it is alternate is it is not equal, right? Purchase is independent is of country. Null hypothesis correct. Now my question is, whenever we are doing any type of hypothesis test, what we are comparing? We are comparing the mean of the samples or the mean of the population. Okay, so null hypothesis is average purchase of Spain is equals to average purchase of rest of the world, and alternate hypothesis is average purchase. Sorry for the typo, it is purchase. Average purchase of Spain is not equal to average purchase of rest of the world. A question over here, guys, using sample mean to check population mean. Yes, so a question over here, can null hypothesis have a greater, equal to, and not equal to sign? Perfect. So this understanding is correct. It is at equality only. And your alternate hypothesis can't have equal to sign. It would be not equal to, greater, or less. It should not have equal to. That is the ground rule that you have. Okay. So from scipy.stats, I'm getting the t-test indicator, and based on, I'm just filtering out over here only, taking all the data which has country as a Spain, the purchase column from there, and taking the other set of the data where country is not equal to Spain and total purchase over there, and getting their p-value. This is what is the p-value, 0.368, which means that it is greater than 0.05. Thus, we fail to reject the null hypothesis, which means that it is not, it is equal to, it is not equal to. It is equal to. Spain average purchase is equal to rest of the world average purchase. Okay, this is t-test that you can create many such problems from this data, from other data that you are working on t-test. There's no specific data set that it would be mentioned that you have to perform hypothesis test only over here. Okay, now I'm going to unveil another test. You might have heard, at least who are my mentees, they would have heard this word from me. Others might have also heard it from their mentors. If not, then we will cover this over here. One question, why can't we have greater than equal to in null hypothesis? So what is your null hypothesis? Null hypothesis is your status quo. It is something that everybody believes in. That is like the universal thing that everybody is believing. You are saying it with affirmation. When you say with something with affirmation, then it is an equal to sign. And null hypothesis is that affirmative statement. When you are diverging from that, you are saying it is not equal, it is not with affirmation, it is greater than, less than, not equal to, then it is alternate hypothesis. Let's move forward. Let's go into ANOVA. Now, every one of you know what is ANOVA, right? ANOVA is what? ANOVA is analysis of variance, but it is a parametric test. It is a test of means only, but in different categories, you can have one-way ANOVA, two-way ANOVA, one-way, n-way ANOVA also. But in ANOVA, what you have only one continuous variable which you are checking for different categories. Everybody agrees to this? Everybody knows this thing? Okay, so in ANOVA, what we have, your dependent variable is always continuous, right? You give something like this, right? Something like this, one column, then a tilde sign, and then C of education, C of marital state. Yeah, Tanya, I'm covering ANOVA. That is not part of your course. This is something extra that I am telling you. So, but I'm asking you if you are clear on the ANOVA, that in ANOVA you have one dependent variable and you can have multiple independent variables. When you were doing the diet problem over there, it was duration and some other thing was also there. That was your continuous columns, and that was your categorical column, independent column, and your dependent column was what? Duration, the number of stay in hospital, right? Everybody remembers this case study? And you have only one dependent column. Now, let's say if you want, you have two columns over here that I'm talking about mostly. That is the total spent and number of purchases. We know that they are highly correlated. If I want to see both of them together, based on, means both are now my dependent variables based on different categorical variables. How will you do? One way is that you will do first ANOVA for only this total spent, and then you will do an ANOVA for total purchase. That's one way that you can do. But what I'm saying is, instead of that, you have something which is known as MANOVA. It is, what is the full form of MANOVA, guys? It is multivariate ANOVA. Yes, multivariate analysis of variance. Can't we use two-way ANOVA? Question. Now, what is two-way ANOVA? Two-way ANOVA also have one dependent variable and multiple independent variable. But I am saying I will have two dependent variable and multiple independent variable. Okay, which determines the effect of independent categorical variables. Okay. Okay. So what I am saying is over here, let me show you over here, guys. Suppose these are two variables, this one variable, this two variable, both are continuous, right? Both are continuous variable. I want to see the impact on amount of wines and amount of fruits together based on different marital status and education. Can you do this with ANOVA? No, you can't do, because in ANOVA, you can only take one dependent variables and multiple independent variables over there, right? That is two-way. If I do only amount of wines and two independent variables, this is what? This is two-way ANOVA. If I take three independent variables, one, it is n-way ANOVA. But I can't take two dependent variables. If you want to take two dependent variables, then that is MANOVA. MANOVA can also be one-way MANOVA, two-way MANOVA, n-way MANOVA. So let's see how to do MANOVA. Now, MANOVA is in stats model again, multivariate.MANOVA, import MANOVA. Two-way MANOVA compares two or more continuous variables by two or more factor variables that you want to do. Can we take more than two dependent? You can take more. It is just more than one. So you can take 2, 3, 4, 6, 8, n number of dependent variables, but it would be MANOVA only. In this case, we can see this is a two-way MANOVA. Yes, this is a two-way MANOVA that I'm taking because dependent variable is two. It is irrespective of number of dependent variable. I'm taking two independent variable. So in MANOVA, you have to define endogenous and exogenous variables. You will learn these terms in time series also. Endogenous means dependent variable. In time series, it is a different concept altogether. And exogenous means these are independent variables. So I took and I created an array which has my dependent variable. I want to see total amount spent and number of total purchases. And then I have exogenous variables, which are two categorical variables, which I took education, marital status. In your independent variable, it doesn't have to be always categorical. You can take continuous also. It is more or less like regression if you take continuous over here. Okay. So I created a data frame which have only these four columns: total amount spent, total amount. You can have more than these two columns also. Okay. That is perfectly fine, but that are dependent columns if you are saying. And this is your independent column that I have marked. Both are categorical. You can take a continuous dependent column also. Since I have taken two independent columns, it becomes my two-way MANOVA. So post this. Now what I did is continuous independent column. How? Continuous independent column, like if I want to see a relationship of education, marital status, and income, I can take income also over here. Okay, let me complete this. I'll show you with income also. Okay. Hold on for the while. So this is right now with categorical. So how you have to define is total spend. Your left side, your LHS is always your dependent column. So these two dependent columns, thus it becomes MANOVA. Now tilde sign based on what? I'm giving two categorical columns: education, marital status, and a interaction between education and marital status also I want to see. This becomes these are my independent columns, and I'm taking more than two columns in my independent variables. Thus it is two-way MANOVA. It is two-way. This part defines that it is MANOVA since I have more than one dependent variable, and this part defines how many variables I'm taking as independent variables. It will tell it is one-way, two-way, or n-way MANOVA. Data is coming from this DF that I created. and then you have to do whatever formula you wrote, .mv test, and this is the output that you will get. This is your intercept part, this is your education, this is marital status, this is your interaction. It gives you different tests. You don't have to worry for all these tests. This is Wilks lambda test, Pillai's trace test, Hotling Loyal's test, Roy's greatest root test, out of which this is still subject to many questions. We don't much go with that. This is still debatable thing. Generally, we look at either Wilks lambda or Pillai's trace test. What it tells you is that education is a factor, or it's a variable which is categorizing, which is differentiating between different categories of education, is a good enough factor to differentiate between, or this is the important factor or impacting factor for your total amount spent and total purchases. Like how you have in ANOVA, same way you will interpret. And since this p-value is very, very less, this p-value is greater, thus alone marital status is not significant, because we also saw that thing, right? Together and single, both are using the same way, right? Both are going ahead and shopping in the same fashion. So this is not much important factor, or it is not having the, you can't segregate much on that category. Interaction is also not having much impact, but yes, education alone has, that we saw already on different country basis, right? So that this is the test of MANOVA that we have. What is the intercept means for us? Intercept is the error, or it is the constant term that you have. You will learn this in linear regression also. You have this intercept, that is your within value. ANOVA is what? SST is equals to SSB plus SSW. What is SSW? SSW is your residual. This intercept is nothing but your residual. So you need not to be worried. This is something which is unexplained with any of these categories. Okay, so what I will do is I will introduce the income column. Let me see it is what's the, let me do it over here only. If we see a number in p-value for intercept, does it mean something? I'm having an, I have introduced, income is what? Income is a continuous column. Now I have introduced part of my exogenous variable or independent variable. And over here also I will take income. Now this is the income column also I have. I will use it in my, apart from interaction, you don't have to give C over here. You have to just give income. There's some error. Oh, sorry, plus sign will come. See, now this is your categorical column. This is categorical column. This is an interaction between two categorical column, and this is your continuous column that I'm having in my independent variable. It is telling you that it is even dependent on your income also. And you already know that there was a high correlation. I can see that, right? That it is dependent on my income. Can we have more than two variable interaction? Yes, I think so. I have not tried that. You can go ahead and try it, but yes, that would be possible. Less than P, you reject the null hypothesis. Yes, when it is less than P, you reject the null hypothesis, and that's what I'm rejecting, my null hypothesis. What is my null hypothesis in Wilks lambda test? That it is not significant. No group is explaining the variance in your variable. But what is my alternate hypothesis? That your groups, different groups in your education are explaining the variable. When I brought in the income, see the value changed. Even now, education is not having the impact, because all the impact has moved to income. Since income and education would be correlated, that's why everything has moved to income, and alone education is not significant. Okay, education is having an impact on which variable? Because we have taken two variables. It is both the variables combination, I'm saying. You can't see for one variable. If you have to see for one variable, then you have to take ANOVA only. If you're saying MANOVA, that I'm saying already these two variables are having, it means the spend and the number of purchases is having a relationship. And thus, you would be able to see a correlation, or you would be able to see the impact between both the variables, not just one variable. How can variable be significant earlier and later with addition to the variable become insignificant? Okay, see, if you look, if you will analyze also, education is based on income. Now already I know that I'm taking income which is overriding my education. Thus it is alone. Now it is alone, it is not significant because it is overridden by income. It is the same part. In each income value is considered as categorical, it automatically converts the data income into categorical. No, it is not categorical. I'm taking it as continuous only. When you take two dependent variables in MANOVA, should there be correct between them? Should there be correlation between them? No, not mandatory that there should be a correlation between them. But if it is a correlation, then at least some correlation would be there. Then it makes sense if you are taking two variables correctly. Then the interpretation makes sense. Otherwise, interpretation won't be. You won't be able to make sense out of that interpretation much. So guys, you learned something new, I believe, MANOVA. Can we check the interaction between categorical and continuous variable? Yes, I believe. I have not tried, but you guys can go ahead and try that. I have not tried, to be very frank. You guys go ahead and try that, whether we can see the interaction or not. Okay. Ma'am, could you please highlight the hypothesis again for ANOVA? Can you please explain the insights using this? Okay. What is the null hypothesis that you have for MANOVA? MANOVA says that for two variables, two dependent variables taken into consideration, that is the total amount and the number of purchases made, they are independent of different categories of education. They are independent of different categories of your marital status. They are independent of your income and all these things. It is totally independent. That's null hypothesis. But your alternate hypothesis says that different categories of education or different categories of marital status or both or with income or anything, at least one of the factors is having impact on your total amount spent and total purchase. So what are the insights that we have? ANOVA, why this, and MANOVA, why? ANOVA is, yes, you have one Y variable and you can have multiple X variables, and in MANOVA you have multiple Y variables as well as multiple X variables also. Your understanding is correct. Okay. Can you please explain the insights using this? What is the insight that I'm getting? Insight that you see the P value for education is not impacting your total spent and the number of purchases. Your interaction between education and marital status is not impacting. Your marital status is not impacting, but the income is impacting. So what I'm saying is income is impacting my different income levels is impacting my total spent and number of purchases. Since this is a continuous variable, I can't say different levels, because if you have to take different levels, you have to bin it over there. Okay. Have a strong correlation bet two variables and using ANOVA. Can we not safely infer the same what we are inferring from MANOVA? Yes, you can definitely infer that thing. That's not a problem. But when you have a statistics test, that is a strong correlation. And as I told you, MANOVA is nothing but another way of doing linear regression. It is a statistics test. Why I'm bringing MANOVA over there, you guys have not covered these. These are some of the things that come in your interview question. You should be aware of it, that how you have to use it. I have not used it personally ever in any of my real-time projects. I have used ANOVA, but I've never used MANOVA over there because I have linear regression. But when you go for interview, these are the questions that you come. Even the question comes from ANCOVA and MANCOVA also. ANCOVA is analysis of covariance and MANCOVA is multivariate analysis of covariance. So that is also something that you should learn. Do you have any plot for MANOVA? No, I have not done any plotting for MANOVA over here. Why one-way ANOVA MANOVA result differ from the results of two-way ANOVA and MANOVA table? It is due to interaction. Yes, it is due to interaction, as well as also you have type 1, type 2, type 3. It is not your one-way, two-way and all that thing. You have, even if you give the sequencing, if you change, your values will change over here in this, because that depends that what it is trying to consider first. That single value, or it is taking the interaction first, or it is not considering the interaction. So in ANOVA also you have one way, two way, and your the type 1, type 2, type 3. Over there also different types are there to consider that what is the thing that you are considering in sequence, and then it will give you the output. Earlier we had education being significant, now only income is significant. So does this mean that we can hide other shallow interactions impact if we add too many independent variables? Yes, that will happen. Your understanding is perfectly correct. And if you know, this is just, again, I'm saying, this is just to show you how MANOVA can be done. This data set might not be the accurate one to do MANOVA over here, but to give you a feel or to explain you what is MANOVA I have done. We have already seen that income, total number of purchases and total spent, they are highly correlated, and that's what we are seeing in MANOVA also. We already saw that in correlation. No need to do this again, but this is just to tell you how to do MANOVA. Okay, so the use case over here, that would be for MANOVA, or not over here in general sense also. As, again, I'm saying we won't be using that much MANOVA in your real time, but you should know from the interview perspective. MANOVA is when you have two dependent variables. Now this goes mainly when you can't segregate two variables. When you say, no, I want to see both of the output together, and both together impact on how they are being impacted based on your different categorical variables. At that point of time, you would be using MANOVA. I don't have any handy MANOVA example right now with me, but this is best that I can explain. What I will do is, guys, I have few of the readout materials on ANOVA and one type, two type. Let me just pull it off. Just give me a minute. Let me show you on screen. This is one. I hope my screen is visible. So this is about ANOVA, ANCOVA, MANOVA, MANCOVA. It is there with an example also with all the theories. They're pretty much easy article, understandable. Okay, then this is ANOVA. 3 types of estimates are there for sum square, so that you don't make a wrong choice. And this is how your interaction changes. Okay, now I'm going to show you some magic. How many of you feel the pain of coding this much in Python for EDA at least? How many of you feel that, no, I don't want to do it, or it is too much? Or how many of you are from management side or new to Python? New to Python, that's all fine, guys. But why I'm going to show you this magic is, please don't use it in your assignments. You will get a beating, and I will also get a beating for that. Please don't do that. But coding is a mess, but coding is fun also. If you understand the concept, coding is definitely fun. Okay. Anyhow, so what I was saying is, over here, don't use it in your assignment. It is for to check what you have done, and in real time, in your real time work also, you can use it. These are something good to know, shortcuts to get your complete visualization or EDA done. And guys, remember, EDA is the most important part that you have. Thus, you need to understand what EDA is telling you. Unless you understand the data, unless you talk to your data, you won't be able to create good models. Okay. So first library that I'm going to, you guys might know. I'm not saying that you might not know, but let me introduce to people who don't know or who haven't used. First library is Detail. Okay. Detail library is recently developed. In future, you will see a lot of changes over there. It was developed in February 2020 only. It was live from there. Import Detail. First, of course, you have to install Detail. It will take some time to install. So be patient. Around 30 minutes also it can take to install that library. So be patient. 30 to 40 minutes or even 1 hour. Import the Detail library. Just give your data set. And this is what I gave. It gave me the view. But what's difference in this view? Why I'm saying it is magic? It is giving you the total number of rows. Okay, will it work with current version? Yes, it will work, Ravi. It will work with current version. Mine is older version only. I think so, older than yours also. So it will work. So this 2237, it tells that how many rows are there. 31 gives you how many columns are there. So it gave you the shape. Now, what's the magic? Magic is this. This arrow is there. Just click over here. You are seeing everything. Describe, hide column, show, clean the column, build the column. You can build new column, merge stack, summarize the data, duplicates, missing value analysis, correlation, predictive power, charts, network, everything you can see over here. That's the most interesting thing. I'll show you on column also. Each column wise also you can go and you can check. See, describe. Let me show you describe. See, describe. It is giving you all the informations for that column. Each and every column you can see over here. Okay. Now what you can see is from here, I'll show you correlation plot. Okay. Missing values, outline. I don't have any missing values. It won't highlight. Highlight D type. See, it highlighted your data types over here. This is date. These are continuous. That's it highlighted like that. Does this package help with probability relation? No. Please don't expect that much also. Na? Everything you can't have the shortcut. At least this much shortcut I am giving you. Be happy with that. Na? Okay. Don't find shortcut to everything. You have low variance flag. You can create new column also. Let me show you how to create a new column. Correlation. Okay. Let me show you the correlation. See, the correlation plot came. View the correlation for which column you want to see the correlation with what column. You can see that also. No module name detail. You have to first install pip install detail. Okay, you have to install that first. Ankita, that will take time. Hold on, you can do it after session. It is available. It is available. It is not that especially I have this available for me. Okay, you can see, you can build column also. See over here. Let it open. You can build the column, how you want to difference, sum, multiply, which column. You can build new column also. You can create bins also over here. Okay, not imputation, it is EDA. It is not imputation, it is EDA that you have. Okay, so this is very good library. It gives you so many things. You can do a great, enormous EDA from this. Okay, now a next cool tool. Okay, now a next cool tool. That is, might be many of you would have heard. It is Pandas profiling. It is also exploratory analysis tool. Let me show you this one. This output, once you store it, it would be stored in HTML format in your working directory. So since I have already done that, it would be stored in the HTML format in my working directory. Full detail discussing how to suppress this chat window pop up on setting. This one. You have to just click outside something, it works. Sometimes I also feel this pain. Yeah, it is suppressed. Click here and there, it will be suppressed. Okay, now let's see Pandas profiling. It is stored in the HTML format. It is also a very great library. I'll show you. Desktop series. Yeah, this is the stored. This is the HTML format. Open for me. Yeah. This is Pandas profiling, something similar to your detail. It also gives you everything. For each and every column, it is giving you how many percentage of zeros are there, missing values are there, infinites are there, how many distincts are there, what is the memory size it is storing, everything. For each and every column, it will give you all the details. This is Pandas profiling. You want to see the interaction? You can see the interaction. Okay, I want to see amount of wines with total purchases. Okay, this is not coming up. Okay, this is, it takes some time to load. So let it load. Then I will come back once this is completely loaded. I'll show you this library completely. This is Pandas profiling. Can you please show how did get the option in detail? Option, which option? Okay, option you are asking this one. This is the arrow. Just click over here. You will get this option. So Pandas profiling takes some time to load. Let it load. How we get Pandas profiling in exam platform? Which exam platform, Akiti, you are asking? Don't ask for your quizzes and all. Quizzes you won't be able to get, but yes, you would be able to get it definitely in your Jupyter notebook. But guys, again, can we copy paste the images to PPT? Yes, you can do. Take a screenshot. Otherwise, you can store it also. Just Google how to save the images from detail, and you will get all those things over there. It generates the report, like how the Pandas profiling has generated this complete report. You can share this complete report also. See, correlation plot is coming. And the best part that I like in Pandas profiling is it gives you 5 different correlation. Read about this. Description of Spearman correlation, Pearson correlation, Candle-Tau correlation, Karmas correlation, Fick correlation, all different correlation it gives with explanation. It gives you about missing values also. This is your sample data that you have. These are the last rows. You can see different interaction also over here. See this one, fish product with this. See, this is the interaction that I have. Let's say amount of wines with your total spent. Where is total spent? Total spend. This is the interaction that I'm seeing. This is Pandas profiling. You get for each and every column all the detail. On top, if you go, if you see over here, you have this. These are your, again, the same different variables you have. It is giving you some alerts. Yes, highly correlated with this. It is giving you details about the high correlations also, which other values it is correlated with. All this informations are there in Pandas profiling. You can see overview. You can go to different variables, see the view, interaction directly. It will take you to this chart. You have correlation view. Missing value view is over here. Matrix, it will show you like this. This is something like a missing no only. Since I don't have any missing value, then it will show you the sample. This is the HTML report you can share with your client anytime. Pandas profiling, what I did is from Pandas profiling, import profile report. Profile report, whatever is your data frame, explorative true. So explore it, give me the EDA, and profile to file, I'm writing it to an HTML file. That's how I get the report. Okay, now another magic library. Okay. The other magic library is known as SuiteWiz. This is for visualization. Again, this report is created in my HTML. I'll go over there, just analyze, and it will show you the report. Okay, this is also open. Yes, this is the SuiteWiz report that I have. Again, for all the columns you have, this is a beautiful report that you have. What are the most frequent values? Click on any of the column, you will get the details, which are the most frequent values, which is the smallest value, and all these things. Everything you would be able to see. Okay, associations. This is your association. This is your correlation plot, and a beautiful way it has been depicted over here. All these things could be visible. Now, another last magic library, or the last magic of the day, that is known as AutoViz. This is auto visualization. Again, a very, very good library. I'm not printing it in HTML. I'll show you over here. All the visualizations are over here. Each and every scatter plot, there are around 120 or so scatter plots would be there. You can see each and every scatter plot over here. You can see, I'm just scrolling and it is keep on going. It is you, for each variable, you have the disk plot, box plot, and the quantile plot. For each variable, you have this thing. See, all you have violin plots created for all your continuous variables. You have, this is also violin plot for your continuous. You have a correlation plot created. All your visualization thing is done in one day. While installing Pandas, there is an error. What is the lib is this? This is AutoViz library. AutoViz. Pandas profiling, you don't need to install the library. You can just go ahead and directly import this from Pandas profile. I think so. It is in Pandas only. Otherwise, you can just try and installing this if it is giving you an error. Is there any package to get insights in wording? My God, no, that's not possible. Do something. How much code we need to write to use this library? So we just need to pass it. Just need to pass the data frame. See, 3 lines. Everything is done. 1, 2 lines, everything is done. Just import and write it. No need to do all this thing. Okay. Do we need to install AutoViz too? Yes, you have to install AutoViz also. Do we use these daily basis? Yes, you can use it. But when you are in the client environment, it depends that what is their version. Like in the client I was version for, their version was older. I can't import Pandas profiling detail over there. But when you are working in startups and it is not that much stringent, you can use all this library. Free flow libraries are there. But for my client was not aligned, so that I can't use that. Okay, so I hope that today's session was good for all of you. We learned many new things. We learned Manova, and then especially Manova and these 4 new libraries we saw. We also did t-test over there, how to do a t-test. You guys have already seen, but I did it over here also. We also saw prior chi-square test, so which you didn't get a hands-on in your Python notebook we saw over there. So I think so. This is it from my side, guys.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.